There
we go. All right. Welcome everyone who decided to join us on this ENCOR study group presentation by myself, Andre Roberge. I am a CCNA as of last year, studying for the ENCOR exam. Plan on taking it probably early 2021 if I get any sort of federal return from my taxes. I'll probably put that towards some exam if I can't get my work to pay for it by then. I currently work in the Washington Air National Guard, like full-time military, as a cyber transport technician. Since February, I've been doing that. And that's kind of like a networking person for the Air Force. And let's see. Today, we are going to be going over exam topic 1.5.a, SD access control and data planes. Here is the overall, here on the left, the SD access, I guess, logical diagram. A bit of backstory on how I decided to go about this study session is I was in an ACI Essentials course about 2 weeks ago, which was a 2-day course, 4 hours each. And they went like directly into like logging into the APIC and going over policies and IP pools, but they never really talked about, you know, how the underlay and overlay process worked within the data center. And for me, coming from a CCNA level, I think it's important to definitely have a bit of a grasp on what you're automating before you begin, you know, logging in and, you know, pushing out config from a central controller. So today I want to go over the overlay and underlay. So we will basically be focusing on everything south of here in today's class. Maybe in a future class, we can discuss how, you know, DNA Center and ICE, how you integrate them, how, you know, ICE uses CTE to push all the security down on the access layer. But today is not that day, and I did not have enough time in my 3 weeks of study to give a whole class on SDA. So where do we begin? I think a good place to start is to look at kind of classical campus designs and then discuss why SDA uses specific, you know, technology within their overlay and underlay and what problems they were solving from traditional, you know, distribution access layer, excuse me. Yeah, core distribution access layer stuff. So in a traditional switched environment, I mean, super traditional, you would just have, you know, spanning tree would be, all this would be layer 2. And then like if you had 2 links to the distribution layer, like one would have to be separated to prevent looping. And, you know, as we got, you know, more involved, there's lots of more different control mechanisms that we can do to try to circumvent the spanning tree. But all that adds complexity into your config. Like, let's see. Yeah, so you can do like, have your root switch control like half your VLANs, and then this one can control half your VLANs. And you have to like correlate your first hop redundancy protocol to correlate to those VLANs and subnets. And as far as like scaling out, like a lot of the failover techniques only have 2 devices at the distribution layer. So if we are to make it a layer 3 fabric between all of these, we would have 1 control plane. So you simplify the config. All of these would just be point-to-point links. between your almost like leaf and whatever, but access and distribution layer. And another big, what I got like to make it easier is the idea of an Anycast Gateway. So instead of this guy being your default gateway for your hosts that are coming out of the access layer, each access layer switch is going to have the same exact config. The Anycast Gateway is going to have the same IP address, same MAC address. It helps for like mobility, so every host can have the same configuration for their default gateway, and it doesn't matter where they plug in at. There's no additional configuration needed. They're going to be able to connect to their, corresponding subnet or VLAN, no problem. So it's just a very easy way to, I think, simplify config. And but you do have one issue in that all these hosts that are still coming off the access switch via layer 2, there's no way for if this guy's on VLAN A and this guy's on VLAN A, there's no way, like if you just have a IP fabric, there's no way natively for that frame to be routed over the IP fabric to this guy over here. So what else do we need? We need a tunneling mechanism to get those layer 2 frames from one access switch to a different access switch over the layer 3 fabric. And I guess I can talk a little bit more about layer 3 fabric before I get into that. So these are going to be like your access switches down here. And then you're going to have like intermediate devices you can have. And then for SDA, for the underlay, they're going to, by default, use ISIS. You can manually configure OSPF or EIGRP. And then the only thing that I think is kind of important to remember, every link between each device is going to be a point-to-point link. And then each device, all what they have to do is to have a network statement for their loopback address. So every loopback needs to be in the routing table, and then all of this in the underlay, like each device needs IP reachability to every device's loopback. And that's kind of the biggest thing I think to know about the underlay. And again, ISIS is default for SDA. Like if you push it out via DNA Center, it's going to use ISIS, but you can manually do whatever IGP you want. Dun, 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 dun. Talked about Anycast Gateway. We need, on top of our layer 3 fabric, a tunneling mechanism. And the most popular tunneling mechanism, I think there was like Trill and Fabric Path in the data center, but everything's moved on, I believe, to VXLAN here. Let's see if I can get out of that. Ooh, there we go. And in VXLAN, you are going to take this would be the entire layer 2 frame from your host, including the layer 2 Ethernet information, and then you're going to encapsulate it, and then this is going to be your frame leaving the access switch. And then the access switch is going to be known, like if this is the access layer here, these are all going to be known as VTEPs, VXLAN tunneling endpoints. And then, so if a host from here is going to send like a ARP to a host over here, this guy is going to, like if he doesn't have it in his cache, he's going to flood to try and find out what this endpoint's address is. And eventually this VTEP over here will be like, he'll flood it out, get it back, and then they can do what's it called? The data plane for VXLAN is natively like flood and learn. So I guess scaling wise, it gets really busy if you're doing flood and learn here. But I guess one more thing I want to mention is that like when this packet gets it and encapsulate it, the outer IP that it puts on is going to be for this VTEP. So this VTEP is then going to receive it and then take off this header information and then send the original layer 2 frame to its endpoint. So all these intermediary devices in the middle, they only have to have IP reachability to the VTEP. They don't have to know anything about the hosts coming off of the access layer that we talked about with the layer 3 fabric earlier. And yeah, the only thing that I wanted to point out again is that the default data plane mechanism for VXLAN is flood and learn. So if you're scaling out really big, that's not ideal. So we need to have on top of VXLAN a control plane to kind of control that native flood and learn learning. Again, I skipped, this was going to be the diagram where I was going to try and explain how VXLAN works in general, but I kind of already did that. Anyways, so yeah, flooding is the issue. So we need something else. Multi-protocol BGP is often the control plane used in conjunction with VXLAN, but in SD access, we use Lisp as the control plane. Lisp works by having a control node. And so instead of like, I guess multi-protocol BGP like is still push. So if this guy was to learn a route, he would push that route out so all these other endpoints can learn it or learn what's behind them. In Lisp, if a host connects to the access point, this guy is going to, there's two different sides to a control node. There's a side in which you register a device, and then there's a side that like answers queries. And in a large scale, you can split that up into different devices, but for simplicity and for this demonstration, we're just gonna have it here in this one control node. If this device connects to the endpoint here, he's gonna look in his cache to see like, oh, do I have this? No, I don't, I need to register it. He sends a register message. This guy is going to build a database with everybody's endpoint identifier to VTEP mapping. So the control plane is going to have every device that connects here to the access layer. It's called EID to, these are RLOCs now. In Lisp terminology, the edge is referred to as RLOC. And so if another device, say like this guy connects and he wants to send a packet over here, this access point is going to receive the packet, look in its cache to see if it already has a endpoint identifier to RLOC mapping. If it doesn't, it's going to query this control node, and this control node is going to be like, hey, you're going to use this RLOC's IP address to send anything to this EID. And so then you put that packet and add the VXLAN header and send it into the layer 3 fabric. And eventually it'll end up over here, get de-encapsulated and send it here to this endpoint. The other aspect to know about this is if this guy over here wants to send a packet to somebody that's not within this this fabric, these RLOCs will have a like a default route to send it to the border nodes up here, and then these border nodes are going to translate like the Lisp terminology into like a regular network and try to find it, you know, up here. And let's see. I think I condensed my whole thing into like 10 minutes today. So that's basically the overlay and underlay, how it works in SDA. The only thing I was going to mention on this big slide here is that this would be like the out of the fabric. This is all in the fabric. So even Cisco DNA Center is out of band management. So you don't necessarily have to have a connection to DNA Center. Everything all the tables and everything are created on each device. So this could hypothetically function without being able to talk to the controller. You just wouldn't be able to update anything. Yeah, I think I made it through everything I wanted to make it through today in this short session. If anybody has any questions.
Are we complete? We have it complete. Sorry, who's left? Who's left?
All right. Does anyone have any questions or experience with SD-WAN that they want to share? Oh.
Yeah, I guess the only other thing I didn't mention is like, as far as scaling capability, like with VXLAN, you have 16 million like VNIDs you can have, and each one of those can carry 4,096 VLANs, as opposed to if you're just doing natively layer 2, you have 4,096. I mean, hardware limitations may limit you to not get to 16 million on your device, but you have a lot more ways to scale out. And I think the Anycast Gateway is like another, I think, genius idea and like an easy way to scale out because all the configs at the access layer. And I guess the next class that I would like to attend in this is how Identity Services Engine and Cisco TrustSec like push security to the access layer. Like I read about it and went through it, but I am not to a level to where I can explain that to a group yet.
So one question hovering over the Celtics all year in terms of their aspirations.
All right. We have a question in the chat. It's like, can you explain the need for underlay and overlay in the LAN? It looks like David actually answered this.
I didn't see the question, but the need is like, you have a layer 3 fabric as the underlay, and you can't natively support layer 2 frames over the overlay or over the underlay. So that's why you need a overlay tunneling mechanism. Otherwise, you wouldn't be able to, like, if your subnet's like dispersed between like 2 different access switches, they wouldn't be able to talk to each other without a tunneling mechanism. I don't know if that makes sense, but that's how I understand it. Yeah, to extend, yeah, layer 2. Whew. How's everybody doing today?
I'm pretty good.
All right.
All right. I'm kind of tapping into some VXLAN stuff with ACI, so this was helpful for me.
Yeah, I just did the ACI Essentials thing, and I thought it was helpful, but I want to read about like multi-protocol BGP, EVPN, like in general before I begin like going through the APIC stuff. So that's on my to-do list for sure.
Yep, I'm working. We have ACI in our data center and are actively migrating to it. So kind of forced to learn it.
Yeah.
It's an interesting technology. Yeah, agree, David. For everyone who's not watching the chat, David said that ACI is cute when it works. And that is so true. It's a nightmare when it doesn't. But new technology.
All right, well, if no one has any further questions or want to chat about anything, I'm gonna go make sure that my older kids are not terrorizing my younger kids and hop upstairs.
All right. Thanks for presenting. It was super informative.
Yeah, it was a lot. I narrowed it down today, but I think I didn't really lose my place as much. I gave the same kind of presentation yesterday. I feel like I did better today. This is like my first time ever presenting in general and over the internet. So.
No, it was great. Thank you, Andre.
All right, thanks everyone. I'll have the recordings for this session and the last two out hopefully tomorrow. I just have to get some files from Erica and I want to send it all together. And if anybody else is interested in presenting, just send me an email. You can just reply back to the email blast that come out. That's a working inbox. It's info@ccieby30.com. We have a question. I would like to know if DevNet, Carlos. DevNet has labs you can do for SD-WAN devices. So if anybody is looking to, get some online practice, DevNet is one-stop shop for SD-WAN stuff. They have some ACI labs as well. If you're looking to get some hands-on. And they also have some DNA center labs, I think, as well. So check out DevNet. That's all I have for today. Thanks again, Andre. And we'll line something up for Wednesday.
All right, sounds good. Thanks for having me.
Thanks, everyone. Enjoy the rest of your weekend.
You too.